Eric Archer here with TI, and today we're going to be talking with chemistry teacher Craig Beals, and Craig is going to introduce us to balancing chemical equations. Craig, what do you have for us today?
Well, balancing chemical equations is another one of those fundamental pieces that you just have to have down if you're going to do chemistry. And really, I've found the best way to get good at balancing chemical equations is practice, 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 because there's an infinite number of scenarios that can happen. And the more practice you have, the better you're going to do. So I'm going to try to lay a foundation for that today.
Awesome. Excited to hear it.
For balancing chemical equations, I definitely want to share what I think is the simplest method to be able to do these. But before we get there, it's important that you know, why do we need to balance chemical equations? So I'm going to start with an example. Let's say we have methane and it combusts to produce carbon dioxide and water. Now, if you can't turn that into a chemical equation and then into a balanced chemical equation, you can't do all the other fundamental things you need to be able to do in chemistry. So we've got to be able to turn that into an equation and then into a balanced chemical equation. So here's the chemical equation. I call this the skeleton equation because it isn't entirely balanced. And we've got over here methane combusts. That means it burns in the presence of oxygen to produce, there's my to produce, carbon dioxide and water. I've put the states of matter on here. They're not included up here in this part, but wanted to make sure to have those in there. Now, the trouble is this. If we really look at that and we examine how many carbon we have on one side and how many hydrogen we have on one side and how many oxygen we have on the other, we don't have the same amount of any of those. Because if I look at my carbon over here, I'm just going to show you on this side, we have one carbon, we have 4 hydrogen, and we have 2 oxygen. Over here on the product side, we have 1 carbon, we have 2 hydrogen, and it looks like we have 3 oxygen. Now, this poses a problem because we don't have the same number of hydrogen on both sides of the equation or the same number of oxygen, which means we can't really go any further with anything in this problem because, well, we don't have all the information that we need. The reason for this, and the main reason we need to be able to balance chemical equations, is because of the law of conservation of mass. And it says that mass or matter can neither be created or destroyed. And what does that mean? In a chemical reaction, the mass of the reactants has to equal the mass of the products, or it's not a true chemical reaction, because the law of conservation of mass says that that mass has to be conserved throughout the reaction. And really, that's the basis for what we're going to learn about. If we go back to our equation that wasn't balanced, you can see that's where the problem lies. We don't have the correct amount in here. Now, I'm going to put the correct amount in here, and then I'm going to share the rules for how I'm doing this to make this really, really easy for you the next time you run into a problem like this. So we know we've got the correct amount of carbons on each side of our equation, but hydrogen is a problem. I need more hydrogen on this side. The only way to do that is to come over here and find where hydrogen exists. I cannot change this number. If I do, I've changed this molecule, and that's not what happens. Okay, I can't do that. The only thing I can do is put a coefficient out front. Let's see what happens. If I put a 2 here, and I say that now I have 2 water molecules, that changes the number of hydrogens to 4, because each water molecule has 2 hydrogens. Well, I can't forget about this oxygen. There are 2 oxygens when I have 2 water molecules, and I still had 2 oxygens here. So that means I have 4 oxygens on this side. Here's where the game starts, because I changed this one, which affected this one, and now I have a different number down here, so I got to come over and fix this side. I just find wherever oxygen exists, right here, I need 4. Oh, look at this. If I put a 2 here, and I have 2 O2 molecules, that gives me a total of 4 oxygens. Now I have a balanced chemical equation. I haven't changed any of the exponents. I've just changed the coefficients out front. Okay. Let me give you what I think are the easiest steps for balancing chemical equations and what we call the T method. I also like to call it the tree method. You'll see why in just a moment. I'm not going to go through all of these reading them to you. I'm just going to kind of put them up here on the screen, and then I'm going to go through them step by step with an example. But one thing you'll learn if you ever take any of my classes is that if you see something with a box around it, you need to have it in your notes. You need to remember it forever and ever for all time. So get it in there and make sure you can find it, because you've got to be able to balance chemical equations all the way through chemistry. If you need to pause this and write it down, go ahead and pause it and write it down. I'm going to jump to an example. So this is the game where we're starting to change everything. I'm sorry, I need to change this up here into a 4. Okay, that gives me 4 of those, 4 of those. So my hydrogen good. Now my chlorine changed. Well, I've got 3 chlorine, and I need to fix that to 4. There's an imaginary 1 here. If I change that to a 2, it's going to change this, and it's going to change my chlorines, because now I have 2 aluminum chlorides. That gives me 6 chlorines. Well, look over here. I need to change this to a 6. So I'm going to get rid of that 4. I apologize for the scribbles. My eraser tool is not working, so I'll clean it all up at the end for you. That changes my hydrogens to a 6, and my chlorine to a 6. And this is what starts to drive students nuts. They're like, this is never going to end. It's just going to keep going on. And I tell them, no, it's not. This is the game. This is the fun game in chemistry. I mean, fun, you have to convince yourself. Now it looks like everything is good and evened out except for my aluminum and my hydrogen. Aluminum's easy. If I go like this changes to a 2. Look at my hydrogen. Oh, it's H2. So if I change this to a 3, look, if I have 3 H2s, that's a total of 6 hydrogens. So in my mess, I feel like we finally have a balanced chemical equation. We have 2 aluminums, 6 hydrochloric acids, reacts to form 2 aluminum chlorides plus 3 hydrogen gas. And this is the game of balancing chemical equations. As I mentioned at the very beginning, the best way to get good at balancing chemical reactions and chemical equations is practice, practice, practice. And on the Nspire, there are several programs on here that will help you practice. In fact, some of these will walk you through very much what I did, but also some practice problems that will help build you the foundation for balancing chemical equations. And there's some really great ones where you can just start to manipulate the numbers and change things until you get this balancing down. You've got to have it down, because once you jump into something like stoichiometry later on, this is the foundation of stoichiometry. You have to start with a balanced chemical equation. And if you can't balance an equation, it's going to be a struggle. So continue to practice these and try out the T method. And I think eventually you'll have it down, no problem.
Craig, that was great. I really like how you broke everything down, simplified it. The T method's a great approach to understanding the coefficients and how they relate to one another on the products and the reactant side. Yeah, and absolutely the files on scienceinspired.com. There's some more practice that you can do with those, with some little simulations. But at the end of the day, balancing chemical equations is foundational to stoichiometry and other things. So great job on this, and really appreciate your approach and how you've simplified chemistry.
And I always remind my students, you got to think of it as a game. It's like Sudoku for chemistry. You're going to make mistakes, back up, change the numbers. You're eventually going to get there. And hopefully when you do get there and have it balanced, you feel satisfied that you've accomplished something quite so complex.
Yeah, good point. Thanks a lot, Craig. Great video.
Thank you.